Hello everybody, welcome to my channel. In this question, I want to go over some chemistry and physics question that you should expect for your exam date. First question, which of the following correctly describes a property of waves? A. The wavelength is the vertical distance between a crest and a trough. B. The period is the count of wave cycles that happen in a set amount of time. C. The amplitude corresponds to the largest downward displacement of the wave. D. The frequency represents the duration of one complete cycle. Okay, for A, the wavelength is not the vertical distance between the crest and the trough. The wavelength, as you can see in, in this picture, is the distance between any two consecutive points on a wavelength. So this one, or between this one, or between this one and this one. So any consecutive points on the wavelength. Okay, next. The period is a count of wave cycles that happen in a set amount of time. That's not correct. Period is the time it takes for one complete wave cycle to pass a point. So that's not correct. C. The amplitude corresponds to the largest downward displacement of the wave. Here we got the amplitude, and it does correspond to the largest downward displacement of the wave. So that's the correct response. D. The frequency represents the duration of one complete cycle. That's not correct, because frequency is the number of wave cycles that pass a point per unit time. And the formula is 1 over t, and t is the period. So number of wave cycles that pass a point per unit time, not the duration of one complete cycle. So D is correct. It's not correct. Second question. Under which condition is a fluid most likely to exhibit turbulent flow instead of a laminar flow? In order to answer this question, we need to know the Reynolds number, the formula for the Reynolds number. So the higher the Reynolds number, the higher the turbulence. Okay? So if the fluid density is high, rho is high, Reynolds number is high too. If the fluid velocity is high, Reynolds number is high too. If the tube diameter is large, the Reynolds number is large too. If the fluid viscosity is large, Reynolds number is small. With that in mind, let's look at the answer choices. When the fluid density is low, that's not correct, because fluid density and Reynolds number have a direct relationship, and Reynolds number is positively correlated with the fluid's turbulence. B. When it moves through a narrow tube, no. Narrow tube, a small Reynolds number, no turbulence. C. When the fluid's velocity is high. Okay, if the velocity is high, Reynolds number is high, which means we have turbulence. So C might be the correct answer. D. When the fluid's viscosity is large. So viscosity is here. It's in the denominator. If it's high, then the Reynolds number is small, which means we don't have that much of a turbulence. So D is not the correct answer. Next question. 0.5 molar solution of an unknown compound is prepared in water. The hydrogen ion concentration of the solution is measured to be 2 times 10 to the power of negative 9. The compound is most likely A. So you know that in order to answer this question, we need to have the pH. And let me give you a shortcut to calculate the pH. In order to do that, we get whatever number that we have here, and we minus it by 2, or whatever number is here. So 9 minus 2. If there was 1 here, we would say 9 minus 1. So 9 minus 2 is going to be 8.7. 8.7 is a weak base. So D is the correct response. Next question. For a chemical reaction with an equilibrium constant 1, which statement is correct? So in order to answer this question, we first need to know the definition for equilibrium constant, or in other words, the formula for equilibrium constant. And as you can see here, the equilibrium constant is the concentration of products divided by the concentration of products. Sorry, reactants. So the concentration of products divided by the concentration of reactants. So if you have a lot of products and not many reactants, that means our reaction is spontaneous, and equilibrium constant is more than 1. If you have many reactants but not many products, this number is going to be less than 1, which means our reaction is non-spontaneous. Now let's go back to the question. Okay, so for the reaction requires an input of energy in the form of ATP. That's not correct. When the equilibrium constant is 1, it means it's at equilibrium. No ATP needed. The reaction generates ATP as a product. No, the reaction is at equilibrium. It does not need any ATP, and it does not produce any ATP. The reaction, if it would produce ATP, then it would be spontaneous. If it would require ATP, then it would be non-spontaneous. C. The reaction has a positive Gibbs free energy change. No. So positive Gibbs free energy change means that the reaction is non-spontaneous. But we know that the reaction is at equilibrium, which means it's neither spontaneous nor non-spontaneous. Also, let me give you a quick maybe trick. If you want to memorize Gibbs free energy and equilibrium constant, know that they're kind of opposite of each other. And by that I mean, if equilibrium constant is larger than 1, if it's a large number, the reaction is spontaneous. On the other hand, if Gibbs free energy is larger than 0, if it's a large number, then the reaction is non-spontaneous, and vice versa. Hope that helps. D. The reaction can proceed in both the forward and the reverse directions. That's correct, because when the reaction is at equilibrium, the reaction is not favoring reactants or the products, which means it can just go back and forth. Next question. Which of the following wavelengths falls within the visible light range? So in order to answer this question, you need two things. First of all, you need to know that the visible light range is between 400 nanometers to 700 nanometers. That's the first thing. Second, we need to know that if you want to turn picometers into nanometers, you need to divide it by 1000. Okay, 8 nanometers is not within the range, 50 nanometers is not within the range, 550 picometers is not within the range. But if we divide this number by 1000, we're gonna get 550 nanometers, and 550 nanometers is between 400 nanometers and 700 nanometers, which means it is within the visible light range. Thank you very much for watching this video. If you want to see more of these videos, please like and subscribe and hit the bell notification so you get notified when I publish one of these. Thank you.